Alright, hi everyone, welcome to my YouTube channel City of Electrons, and in this video we'll be talking about something we are going to make use of later on, and that is phasor diagram. Actually, what we just need is how to represent voltage and current in form of in angular form, okay, in angular form, or like kind of phasor. The thing is, we are dealing with voltage and current which is alternating, okay, and of course that means that's a sinusoid. Okay, so a phasor is a complex number that represents the amplitude and phase of a sinusoid. That's just the idea of a phasor. Now I want you to notice this: when our voltage and or current changes, that's alternating current. When it alternates, we have this wave signal or wave form. So the thing is this: let's say we have this for voltage, okay, let's say this black line is for voltage, and let's say this red line is for let's say current. Okay, let's say that's for current, and we have the current like this. This is not that perfect, but it's not perfect, but oh boy. But I just, yeah, manageable. Okay, so the thing is this: right now at this point we have, yeah, at that point, that's where we have our voltage. Let me draw this back a bit. So let's say at this point, good, manageable. So at this point, this is where our voltage is. Let me use other color. So this for the I is for current, that's the red line, and then take the dark line for voltage. Okay, let's just take it as that. So at this point, at this very point, this is where we have our voltage. Okay, that's where we have our voltage. Then at this point, this is where we have our current. Okay, so this is the wave form of our voltage, and this is the wave form of our current. Okay, I believe you can see that. Now, if to make this calculation easy for us, we make use of phase or phasor. What that means, we use a spinning vector. This is what we mean by that idea of spinning vector. Just take, imagine we have, you know, vector has magnitude and direction. So let's say we have this as a vector. Okay, so when we have voltage at this point, our vector will spin or will rotate in this direction. It rotates in this is conventional direction. Okay, so when we have voltage at this point, we are going to have it like this. So that point is this is where our voltage is. Therefore our current, we have it at this. Let me use black again to make it easy. So for our voltage, we have it at this point. Okay, then for our current, we have it at this point. This line is not perfect, like it's not straight enough, but I just hope it gets the point across. So the thing is this: since then at this point our voltage will be here at this point, like this will be at this point, then our current will be here. Now if you look at this, you see that we can draw an angle. Like, let me see if I can zoom in here better. At this point we can draw an angle. Okay, we can draw an angle. Okay, obviously the angle of the voltage is higher than the angle of the current. Okay, and we see that we get our angle as a result of the amplitude of the waveform of the sinusoid. We got our result by marking a particular point. Let's say, okay, at this point, what is the amplitude? They will now take a spinning vector, which is this, and rotate it anti-clockwise to match the particular point of the current amplitude of the voltage and then of current, and then we'll now see that that of the voltage is higher than that of the current. In this case, we'll now say this is lagging. But don't worry, lagging and leading, we'll talk about that later. But just from looking at this, it's obvious that the voltage is higher than the current in terms of phase, in terms of angle. So if that happens, we say that the power factor is lagging. Look at this. Okay, now forget about the first part, just look at this down part. Leading or lagging has to do with the phase angle of IS and VS. IS is the sending end current, VS is the sending end voltage. Okay, so then when the phase angle of the sending end current is greater than the sending end voltage, then we can say the power factor is leading. Conversely, when we say the angle of the sending end current is less than the sending end voltage, then we can say the power factor is lagging. Now just look at it. It's just like current is the main guy. Okay, so if current is behind, we say it's lagging. If current is ahead, we say it's leading. That's the power factor is leading. So we are able to determine who is lagging and who is leading by drawing this order diagram using this order diagram using a spinning vector. Now this order diagram, if we ignore this other parts, and think of just this other part, this will give us a phasor diagram. Okay, now I've told you, we've said that this is a V and the red is a I current. Okay, so let's redraw this, but with just this part. Okay, with just this part. Now you see that we are using, of course the complex number will come in very soon, you will see that. Okay, but just bear in mind that instead of using sinusoids, okay, we want to use a complex number to represent the amplitude and phase. This is the amplitude. These angles we have here is as a result of where our wave is. So we are using the amplitude, using a complex number to represent the amplitude and wave of this sinusoid. So the next thing to note is that instead of looking for how to represent or how to work with these sinusoids, we can just work with the phasor form or the angular form, which is for our voltage, to represent voltage of receiving end or sending end, but of receiving end here, all we have to do is use its magnitude and then its angle. Finish. We finish. But that's all. So of course the angle will be here. Let me zoom in. So this will be the angle for voltage and then the angle for current. This is quite small, but we can see that. So this, of course, like the definition here, that a phasor is a complex number that represents the amplitude and phase of a sinusoid. So this is a complex number but in angular form. Okay, now of course we can put this in a rectangular form. By taking the sine and cos of this. Of course we include the magnitude to it. That is, if we want to put this in rectangular form, all we have to do is to say V equals, now this VR multiplied by cos the angle plus J sine the angle. So of course this is a complex number because here we have it. Okay, J, complex number. So now we have been able to represent these sinusoid. Okay, represents the amplitude and then represent the sinusoid using a complex number. Of course, this is still in a angular form though. It's still in an angular form, both in angular form. Then for rectangular form, what we have to do, okay, so what's the cos of this angle? I don't have a number there. So when you take the cos of this angle, okay, you multiply it with this, you have a number here. Okay, you take the cosine of this angle, multiply with this, you have a number here. Plus, you take the sine of this angle, multiply it with this, you have the number here. That will be in the rectangular form. Okay, so of course, subsequent videos we'll work examples and see how we do this. Okay, so this part we have here is the phasor diagram. If I can copy that and expand it, okay, of course the phasor diagram will be larger than this, but at least this gives the point a bit. Okay, gives the point a bit. It tells the point a bit. Okay, the current is kind of the the main guy we judge from in terms of leading and lagging. If the current, if this angle, let's do the one for current. Okay, so we also have a current. Of course, we have the current and then its angle. Okay, its angle. Oh boy, its angle, which we can also bring to this format, and then get the cos multiplied by the magnitude, the sine multiplied by magnitude, and have it in a rectangular form. So if this angle is greater than this angle, then the power factor is leading. If this angle is less than this angle, the power factor is lagging. For lagging power factor, this current will be negative. For lagging power factor, okay, the angle will be negative. The angle will be negative. For leading power factor, the angle will be positive. Leading power factor, the angle or the phase will be positive. Then for unity, guess what? For unity, what's gonna happen? Think of it. Leading and lagging is negative, leading is positive. Unity, what's gonna happen? What? Zero. That's it. Okay, it's going to be 0. So we are going to need this later on, so just bear this in mind. We're going to need all this later on in our calculation to make things easy for us. Okay, so I guess that's all for this video. So yeah, if you have any question, comment, anything, put it in the comment section. Like, share, subscribe, send notification, or click on notification bell and subscribe. So thanks for watching, and I'll see you in the next video. Short 3-phase line.